In this video, we are going to discuss how to use the expression for kinetic energy, potential energy, and the law of conservation of energy to solve problems. The question says, the illustration below shows a box on a curved, frictionless track. The box starts with zero velocity at the top of the track. It then slides from the top of the track to the horizontal part at the ground. Its velocity just at the moment it reaches the ground is 14 meters per second. What is the height h from the ground to the top of the track? So here they have given me a box which is on the top of a track, and the velocity of the box on the top, I will call it v initial, is 0. The box slides down the track and reaches the bottom. Just as it reaches the bottom, its velocity, which I will call the final velocity, is 14 meters per second. They want us to find what is the height of the track. The law of conservation of energy says that if I have a system like the one described here, and I take any 2 points on my system, so let me call this point 1, the top of the track, and the bottom I will call it point 2. According to law of conservation of energy, total energy at point 1 must be equal to total mechanical energy at point 2. Now, total mechanical energy at any given point is the sum of the kinetic and potential energy at that point. So I will write this E1 and E2 in terms of sum of their kinetic and potential energy. Now let's discuss what are the energy values at these 2 points. At the highest point, since my velocity is 0, kinetic energy at this point will also be 0. Since kinetic energy is equal to half mv squared, where v is the speed or velocity. If at any point this velocity is 0, kinetic energy will also become 0. But potential energy here, since it is raised at a height h above the ground, this place here will have potential energy. At the bottom, on the other hand, the object has a speed v. And since it has a speed, it will have kinetic energy, but it is not raised to any height here. So potential energy at this point will be equal to 0. So point 1, the highest point, has only potential, no kinetic. And point 2, the lowest point in motion, has only kinetic, no potential. So using this, I can write that potential energy at the top is equal to kinetic energy at the bottom. Now, this is an important expression when we are solving problem. If I have an object which is raised at a height h above the ground, the object has only potential energy at this point. And when it comes down, this potential energy is then converted to kinetic energy. Potential energy is given as mgh equals kinetic energy will be half mv squared. You can cancel off the m here, m and m. I want to find what is h, so we will divide with g on both sides. If I want to find h, I need to get rid of g, and in order to get rid of g, we have to divide with it on both sides. So I will write h equals half v squared over g. Now let's substitute half. This v at the bottom is my final speed v. So half times v is 14 squared over g is 9.8. And when you solve this, you get your height as 10. Let's discuss the next question. A bike rider approaches a hill at a speed of 8.5 meter per second. The combined mass of the bike and the rider is 85 kilograms. Choose a suitable system. Find the initial kinetic energy of the system, and the rider coasts up the hill, assuming friction is negligible. At what height will the bike come to rest? So let us first sketch the situation. I have a hill and a bike rider with an initial speed v goes up the hill and then comes to a rest at a certain point. So initial speed is vi. I will write my vi equals 8.5 meter per second. And when he coasts up at a certain point, he comes to rest. So at whatever height he comes to rest, at this point, my velocity, which I will call v final, will be 0. Since the object is at rest, velocity at that point has to be 0. So I will write v final equals 0. First part of the question is asking you to choose a suitable system. So my suitable system here in the first part, I will call this part A, will be the earth, the rider, and the bike. Because all interaction are happening between these three things. So these are the three things which I will choose to be my system. Second part of the question wants me to find initial kinetic energy. We will call this the second part. Kinetic energy is nothing but half mv squared. And since they want me to find initial kinetic energy, this v I will take as the initial velocity. So let us solve. Half mass of the rider here is 85.0 kilogram. We substitute half times 85.0. V is 8.5 squared. And when you solve this, you get your initial kinetic energy to be equal to 3070.6 joule. Third part of the question is telling you the rider coast up. When it says coast up means the rider is moving up without pedaling, without applying any force. So here the force applied by the rider will be equal to 0. So he is moving up with only the initial kinetic energy that he had before he went up the hill. He is not applying any more energy in the system while he is going up. So whatever kinetic energy you had at the bottom here is then converted to the potential energy of the rider at the top. So I will use that expression. We call this part C. Kinetic energy at the bottom is converted to potential energy at the top. Now we substitute kinetic energy. We know it is half mv squared equals potential energy is mgh. You can again cancel off the common terms m and m here. I need to find what is h. If I want h, I need to get rid of g. G is multiplied to h. So if it is multiplied to h, in order to get rid of it, I will divide by g on both sides. So we can write h equals half v squared. I will write as it is, divide by g. Solve this. Half initial velocity is 8.5 squared divided by 9.8. And when you solve this, you get your answer as 3.68 meter, or you can round it off to 3.7. So please remember this expression whenever an object is moving and there are only conservative forces involved. Whatever potential energy is stored at the top of the motion is equal to the kinetic energy at the bottom, or kinetic energy at the bottom must be equal to potential energy at the top. Kinetic energy will be half mv squared and potential energy will be mgh. And when you equate these two terms, you will either be able to find what is the speed at the bottom or what is the height the object is raised to. To make it easier for you, one simplified rule for calculating velocities in such cases is v equals square root 2gh, and height is half v square over g. So anytime you have a problem like this, if you can remember these two expressions, it will be easier for you to find either the height at which object is raised to or its speed at the bottom. Question 17. Suppose that the bike rider in the previous problem pedaled up the hill and never came to a stop. In what system is energy conserved? From what form of energy did the bike gain mechanical energy? So in this part of the problem, here the bike rider is pedaling up. So if he is pedaling up, he is applying a force to move up and he doesn't come to a stop. The system again will be the objects which are interacting, the earth, the rider, and the bike. But here, there are other forms of energy involved too. And why is that? Because when the rider is applying a force, when the rider is applying a force, he is using his chemical energy. And when he applies that force, he uses his chemical energy and converts that chemical energy to mechanical energy. So chemical energy of the rider is converted to mechanical energy of the system. Whenever we do work, we use chemical energy stored in our body. So if you're running, lifting an object, pushing something, you can apply that force with the help of the chemical energy stored in your body. So the bike gain mechanical energy from the chemical energy of the rider.